Welcome back to Learn Civil Easy. This is the solution video for the 25 question practice paper on why steel in concrete. If you have not attempted the paper yet, pause here. The link is in the description and it is free. We will go through every question in order, and for each one, I will not just give you the answer, I will show you why the wrong options are wrong. That second part is where the marks actually are. Let us begin with section A. Section A, Concepts and Definitions. 10 questions. Question 1. Steel is provided in a concrete member mainly because concrete is weak in. The answer is option 2, tension. That is the whole subject in one line. Concrete takes the push, steel takes the pull. Question 2. As per ICE 456, the flexural strength of concrete is taken as option 1, 0.7 root FCK. Now look at the three wrong options because each of them is a real formula you will meet later. 5000 root FCK is the modulus of elasticity of concrete. 0.446 FCK is the constant in the limit state stress block. And 0.87 Fy is the design stress in steel. If those four blur together now, they will cost you marks later. Learn them apart. Question 3. The tensile strength of concrete is roughly what fraction of its compressive strength? Option 3, about 10 to 15%. Most books say 1/10. By the code formula, it is closer to 13 to 16%. And here is the part worth remembering. As the grade goes up, that percentage comes down. M20 gives 16%, M25 gives 14, M30 gives 13. Concrete never gets good at tension. It only gets better at compression. Question 4. M25 means a characteristic compressive strength of 25 newtons per square millimeter, which is option 4, the value below which not more than 5% of test results are expected to fall. Option 1 is the trap, and it catches a lot of people. Characteristic strength is not the average, it is the 5% lower fractile. The average target strength used at mixed design is deliberately higher than this. Question 5. The neutral axis is the line along which option 2, bending stress and strain are 0. Option 3, the main steel is placed is the interesting distractor. The main steel is placed as far from the neutral axis as we can put it, because the further away it sits, the bigger the lever arm and the bigger the moment of resistance. Question 6. Which of the following is not a reason why steel and concrete work together well? This is a not question, so read it twice. The answer is option 4. Steel and concrete have the same modulus of elasticity. They do not. Steel is about 2 lakh. M20 concrete is about 22,400. Steel is roughly 9 times stiffer. That difference is exactly why the modular ratio exists. Question 7. The modulus of elasticity of steel is 2 times 10 to the 5 for option 3, all grades of steel. Only the yield strength changes between Fe 250, 415 and 500. The stiffness does not. This pairs directly with question 6, and together they are one of the most common misconceptions in the subject. Question 8. Functional design is primarily concerned with option 2, room layout, light and ventilation. Options 1, 3 and 4 are all structural design. Functional design asks whether the building works for the people inside it. Structural design asks whether it will stand up. Question 9. The correct order of the structural designer's work is option 4. Structural planning, then calculation of loads, then analysis, then design, then detailing. The order is not arbitrary. You cannot analyze until you know the loads, and you cannot know the loads until the layout exists. And please do not treat that last stage as an afterthought. A perfectly designed beam with wrongly detailed bars will still fail. Question 10. A symmetrical plan is preferred mainly because it reduces option 1, torsion under lateral loads. When the center of mass and the center of rigidity sit at the same point, a push from wind or an earthquake moves the building sideways. When they are apart, the same push twists it, and twisting is what tears buildings apart. Section B, Bar positions, cover and the codes. 12 questions, and this is the heart of the paper. Question 11. In a simply supported beam carrying a downward load, The main reinforcement is provided option 2 at the bottom throughout the beam sags. So the bottom fibers stretch, so the tension face is the bottom, easy. Now hold on to that because the next question breaks the habit you just formed. Question 12. In a cantilever beam, the main reinforcement is provided at the option 3, the top face. This is the single most missed question in this whole chapter. Do not just take the answer, derive it. The free end of a cantilever drops, so the top fibers are being stretched and the bottom fibers are being squeezed. The beam is hogging. The tension face is the top, so the steel goes at the top, and it must be anchored back into the support because that is exactly where the moment is greatest. Question 13. In a continuous beam, extra top bars are required, option 4 over the intermediate supports. Option 3 is the sharp distractor. At the points of contraflexure, the bending moment is 0. So that is precisely where flexural steel is least needed. Question 14. The point of contraflexure is the section where the bending moment, option 2, changes sign and is 0. It follows directly from question 13. On the moment diagram, it is where the curve crosses its baseline. Question 15. Clear cover is measured from the concrete surface to the option 3, the surface of the nearest bar, that is the stirrup. This is the classic cover trap, option 3. In the paper, the centroid of the tension steel is not clear cover, that is effective cover. A good student picks that one, which is exactly why it is there. Question 16. The nominal cover for a beam under mild exposure as per IS 456 table 16 is option 2, 20 millimeters. Straight value recall and precisely the kind of question SSCJE asks. Question 17. The effective depth is measured from the extreme compression fiber to option 4, the centroid of the tension reinforcement. Not the bottom face, that gives you capital D, the overall depth. Small d is the depth that actually resists bending. Question 18. The primary function of stirrups is to option 1, resist shear and hold the bars in position. Both halves of that matter. The second half is the practical one that textbooks skip. Without stirrups holding the cage, your main bars move while the concrete is being poured and your effective depth is no longer what you designed. Question 19. Which code gives design aids, charts and tables for reinforced concrete to IS 456, option 1, SP16? Keep the family straight. SP16 is design aids, SP34 is detailing, IS 875 is loads, IS 13920 is ductile detailing for seismic forces. Question 20. IS 13920 is necessary because an ordinary IS 456 frame, though strong enough, may lack option 3, the ductility to absorb energy during an earthquake without collapsing. The diploma syllabus asks for the necessity of this code by name, so it is directly examinable. Remember it as one sentence. IS 456 keeps the building standing under load. IS 13920 keeps it standing after the shaking. Question 21. In the working stress method, concrete below the neutral axis is assumed to option 1, carry no tension at all. And note this is true in both methods, not just in working stress. Students often think it is a WSM only simplification. It is not. Question 22. The single most important advantage of the limit state method over the working stress method is that it, option 4, applies separate partial safety factors to loads and to material strengths. Option 1 always gives a shallower section is the trap, and it is the answer most students give. Economy is a consequence of limit state design. It is not the reason for it. The reason is that load uncertainty and material uncertainty are two different things, and they deserve two different factors. Section C. 3 numericals. Watch the units. Question 23. For M25 concrete, the flexural strength equals 0.7 root FCK, substituting 0.7 times root 25, which is 0.7 times 5, which is 3.5 newtons per square millimeter. Option 2. Now look at the wrong options because each one is a specific mistake. 2.8 comes from using root 16 instead of root 25. 4.38 comes from root 39. and 17.5, that is 0.7 times 25. Somebody forgot the square root entirely. That is the most common slip in this whole calculation. So slow down on it. Question 24. A beam has overall depth 400 mm, clear cover 25, stirrups 8 mm diameter, and main bars 20 mm diameter in one layer. Find the effective depth. Effective cover equals clear cover plus the stirrup diameter plus half the main bar diameter, that is 25 plus 8 plus 10, which is 43 millimeters. So the effective depth equals 400 minus 43, which is 357 millimeters. Option 3. The wrong options are each one missing piece. 347 uses the full bar diameter instead of half. 367 forgets the stirrup. 375 uses the cover alone. Draw the section, mark the three pieces, and you will never lose this mark. Question 25 for Fe 500 steel with gamma m equal to 1.15. The design strength of the steel is 500 divided by 1.15, which is 434.8, so approximately 435 newtons per square millimeter. Option 1. And now the part worth carrying with you, 1 divided by 1.15 equals 0.87, that is where the 0.87 Fy in every single limit state formula comes from. Most students use that number for 2 years without ever knowing why. Now you know. So count your score. 22 or above is excellent. 16 to 21 is a good solid score. Below 16, do not be discouraged. Go back to the concept video and watch the 3-bar position cases again, because that is where most of the marks in this paper sit. One more thing, if you were guessing, you may have noticed the answers do not favor any one option number. That is deliberate. 6 answers are option 1, 7 are option 2, 6 are option 3, and 6 are option 4. You cannot game this paper. You have to know it. The study notes for this topic are on our Telegram, free, with every definition, every formula with its code clause, and 5 worked examples. And in the next video, we begin the second piece of this subject, loads on structures, IS 875 and IS 1893. See you there.